Hello and welcome to the online classes of computer science with Python. This is Renuka and our today's topic is about queues in data structures. In our previous video we have discussed about data structures and stacks, various inbuilt data structures, various user defined data structures, and in user defined data structures we have discussed in details about stacks and its implementation. In this video we are going to discuss about queues in data structure and how they are implemented using list in Python with the help of a Python program. Now what are queues in data structure? Queue is a linear data structure. We have discussed that in data structure, user defined data structure, there are trees also. But trees are not linear data structures. So stacks and queues and list are linear data structures. So in queue, as we see queue in the daily routine life, that the customer who comes first will be served first in the queue. So this queue also for data storage in computer memory also works on the principle of first in first out. First in first out means whatever item that is inserted first in the array or list, that will be taken out first, and the item which is added at the last will be served or taken out at the last. So that is a queue. The first part, front part, is front, and the end part, or we can say the last part, that is known as rear. So all the additions are done from the rear end and all the deletions are done from the front end. So that is what a queue are. So important points that we have to remember about queue, that queues are open from both the ends. So as unlike in stack are open at from one end. From one end you are putting values, and from that end only you are taking out the values. So that's why it was working with the on the principle of LIFO, that last in first out. But queues are open from both the ends, and so from both the ends, and that's why form addition is from the back and removal is from the front end, and that's why it works on the principle of first in first out. But whichever item will add first, that will be removed first. And if all the items are removed, then the queue is empty, and in that case, if from empty queue, if we want to remove some element, it will generate an error message. And if the queue is full, then no more items can be added. In that case also there will be a error message. So if adding an element to queue, that is known as NQ, and removing an element from a queue, that is known as DQ. And random access is not allowed in queue. You cannot take out the third item or fourth item. They always will move in sequence order. So how that insertion or deletion in a queue will work, we will understand with the help of example. So this is a queue with indexing 0 1 2 3. So this is empty. So if first element is added, so in case of empty, head and tail are both the pointers at the 0. So when first item is added, then head will move to 27 and tail will move to 1. So index for first item, that is 0, that will come in head, and here it will come in tail next. Likewise, as we are moving other items to the queue, head will remain same, that is at the first object, or we can say at the 0 index, but tail will move accordingly. So it will move to the last item, next box to the last item, so that new item can be added to this part. So tail, or we can say the rear end shows the pointer where we can insert the new item here. So that is tail part. And now if we want to delete, so deletion will be done from the head part, or we can say the front end. So first 27 will be deleted, as 27 will be deleted because it is the head part. So the next the head pointer will come to 19. Now 19 will become the front part. Now as 19 will be deleted, then after that 17 will become the head part, and after 17, 7 will become the head part, like this. So at the time of insertion, tail is moving 1 forward, and at the time of deletion, head pointer is moving 1 point forward. So this is how addition and deletion are possible in queue. We will understand once more. If we are adding one element in the queue, that in that case head pointer will point to that element and tail will move to next one. Then next item if we are adding, so tail will move to next pointer. So from the rear end we are adding the items, so addition is possible from the rear end. From the rear end we are adding, so that's why tail is moving towards right hand side, 1 index it is incrementing. And at the time of deletion, when first item is deleted from the front end, then head will move to the next pointer, next item pointer. So in that case, after the removal of 19, 17 will become the first node. So like this queue are working. So we'll understand the working of a queue with the help of example. So this is an example where we have taken employee as an empty list. So that this is an empty list declared and character C is declared as Y. So we will move until C is Y. Means if C is yes, we will repeat the complete process again and again. So we are taking three menus: insert, delete and display, and taking choice from the user. If user is giving 1, then insertion in the queue, 2 then deletion from the queue, and 3 is for display. That means all the elements of the queue will be displayed. So first we will check the choice entered by the user. If it is 1, that means we want to take one element from the user and store it in B. And then employee means that is the empty list, append B means we are adding that element to B. So then it will move to last line. Do you want to continue or not? If we say yes, then again it will display this. And next choice, if second item you want to insert, same procedure will be repeated again and again until you say no, or you can take another choice, delete or display. Now for if the choice is delete, in that case it will check first, it will check this is for delete. So first it will check if the list is blank, okay, null. In that case it will print that the queue is empty, else it will delete the very first element and with a message that this item is deleted. After deletion, if you want to display the list queue again, in that case you can choose the choice 3 and you can display. This is for display. Now after deletion, if we are displaying, then it will show us the list of items with removal of the first item. अगर हम पहला item remove कर रहे हैं और फिर display कर रहे हैं, तो वो हमें display में वो पहला आइटम नहीं दिखाएगा, सेकंड से लास्ट तक सब दिखाएगा. सो डिस्प्ले में वह फर्स्ट वी विल टेक द लेंथ ऑफ आवर लिस्ट, then starting from I in range 0 to L, because we are starting from 0, so that's why it is L. अगर लिस्ट में 3 आइटम्स है तो ये 0 से 2 तक चलेगा और प्रिंट करेगा एक एक आइटम, एम्प्लॉय 0, एम्प्लॉय 1, एम्प्लॉय 2, लाइक दिस. so it will print one element. और अगर इनमें से कोई भी केस नहीं होता, if choice is not 1, 2 or 3, in that case means your input is wrong and it will give you the message that wrong input. We can see this program, how this program will execute. We'll make this program in Python file and we'll make it run. It is already there, so we'll make it run. So this is how it will first show the menu. Then if we say choice is 1, in that case it will ask for new number, it is 15. Again choice, we want to enter second number, it is 15, and then we want to display, suppose that is 3, so display 5 and 15, 5 and 15 it is displaying. Now we want to delete, enter a choice 2, deletion, and it is saying that deleted item is 5. After deletion again we want to display, and we can say that it will show us the, if we say 3, okay, we have already said this is wrong output. So again we can run our module, and we can see that when we'll say 3, it will show us the only one item remaining in the list. So that is how we can implement list as a queue. And various applications of queue where we can use queues in computers or day-to-day life. So in call centers, when there are phone calls for attending a person, so those phone calls are arranged in a queue format by the computers or the service center. So whichever call is in the first order or at the first place, that will be served first. Likewise, handling of interrupts in real-time system. If interrupts are there while working on a system or in an operating system, so those interrupts will be handled according to the first come first serve basis. Then serving request on a single shared resource like a printer CPU task scheduling. If CPU is task scheduling and there is a request for printer, so the user which comes first will be served first. So these all are the various applications of queues that we can see in our day-to-day life. Thank you, and